Welcome to the US EMV Value-Added Reseller Qualification Program's educational webcast series, brought to you by the Payment Security Task Force and EMV Migration Forum. Hi, I'm Derek Ross from ICC Solutions, and I will be providing a brief on EMV technical details and lessons learned. Okay, the first question: what considerations are in place for more data being sent with each transaction? Typically, an EMV transaction will increase the data sent with each transaction. However, this isn't a bytes to megabytes question. It is relatively incremental and should not impact processing bandwidth. Of course, this will have a minimal impact on transaction times and data processing due to the enhanced security aspects, but this is relatively small due to the existing online infrastructure of the US card payments market. And the next question: how does a chip transaction happen? What is the nature of card-device terminal interaction? A chip transaction is a bit like a game of tennis where the card and terminal are players. If a chip card is being swiped at an EMV-enabled terminal, the terminal should prompt the card to be inserted. Fundamentally, there are three main steps to a chip transaction. Firstly, mutual authentication, where the card and terminal use certificates and cryptography to check that their counterpart is genuine. Secondly, presentation, where the card presents the cardholder details and the terminal presents the details of the transaction. The terminal determines the application supported by the card and compares them to the application supported by the terminal for a mutually supported application. It will depend on the application supported by the chip card for the decision making. If one application, that application will be used. And for multiple applications, the terminal would display a list of applications for cardholder selections. For debit, refer to the debit webcast for more details. Thirdly, decision making, where the card and terminal work together to make the decision on the transaction, either locally or with the online assistance of the issuer. Being effectively a small computer, a chip card interacts directly in the transaction in a way that magstripe cards cannot. It can prove that it is genuine through shared certificates and cryptography. It carries the cardholder details and can provide them securely with static and dynamic elements. And it can work with the acquiring infrastructure to make a decision on whether the transaction should be approved through improved cardholder verification and dynamic risk parameters provided by the card issuer. Next question: when deploying EMV, what other security solutions do I need to consider? For example, end-to-end encryption. EMV technology is focused around the interaction between the card and the terminal, which is why it can't be used for card-not-present transactions. What this means is that basic EMV secures uniquely the transaction prior to it entering the payment network. Recently, EMV Co. have introduced the EMV tokenization guidelines, which allow replacement of data in the EMV messaging with tokenized data, and so enhancing transaction security greatly by taking replayable data out of the messages. Immediate or future support for tokenization should be a consideration when you are designing your acquiring network. Naturally, you should seek to make your systems compliant with the PCI DSS standards to reduce vulnerabilities at every point. Additionally, depending on your configuration and the types of terminals being deployed, you should integrate point-to-point encryption or other types of end-to-end encryption if supported by your acquirer. You can receive comprehensive support on deploying and certifying security components from expert vendors. What lessons have been learned from early implementations and merchant education? The key success factor for EMV migration in other markets, such as Canada, United Kingdom, and Australia, has been the availability of education materials and training for all sectors impacted. This includes merchants, cardholders, and everyone in between. Although there is no central body driving all education initiatives in the United States, courses and supporting materials are readily available from payment networks, industry associations such as Payment Security Task Force, EMV Migration Forum, the Smart Card Alliance, and accredited service providers. The migration to EMV includes changes in behaviour that have not been seen since the introduction of magstripe over 50 years ago. It is important that you educate all the merchants connected to your network in order to reduce interoperability issues and ensure easy adoption of the technology. In a time of change, communication can be a stronger differentiator than price, as the cost of problems will multiply as the migration goes forward. Next question. What is a selectable kernel? Do I need to support it? A selectable kernel is a piece of software that incorporates various switches to activate or deactivate functionality or behaviors. Any merchant who is eligible under the no CVM limit policy as defined by the individual brands and wants to leverage no CVM limit transactions needs to ensure that a selectable kernel is deployed that will enable the merchant to invoke no CVM based on dollar amounts and ensure a smooth consumer experience. What is fallback? Fallback is the process when there is no capability to process a chip transaction due to a damaged chip card or terminal, or incorrect terminal capability coding. It is referred to as fallback because in a list of card authentication priorities, chip has the highest priority, and if it is not available, the transaction falls back to magnetic stripe. Basically, fallback is a transaction made with a chip card and a chip reading terminal that is not a chip transaction and does not benefit from the security of chip technology. In closing, consult with your acquirer and payment network for more details on their EMV implementation requirements. Thank you.